Okay, so let's do our Thursday verse. Everybody pull it out. And it starts with, you see, at just the right time, when we were still powerless, Christ died from the get-go. Very rarely will anyone die for a righteous man, though for a good man someone might possibly dare to die. But God demonstrates his own love for us in this: while we were still sinners, Christ died for us. Since we have now been justified by his blood, how much more shall we be saved from God's wrath through him? For if, when we were God's enemies, we were reconciled to him through the death of his Son, how much more, having been reconciled, shall we be saved through his life? Not only is this so, but we also rejoice in God through our Lord Jesus Christ, through whom we have now received reconciliation. Okay, on this part of your 57, we're talking about sinusoidal functions again, and we're talking about what happens when we shift them. This is called the phase shift. So the first thing we want to talk about, your book talks about also, is remember we've shifted functions before. We have translated them around the axis. And this is the function y is equal to x squared is the parent function. It's a parabola. It's not a sinusoid. However, we're going to treat them all the same. Okay? So if I'm going to slide y is equal to x squared here at 2, so that the center is no longer 0, but the center is 2, what is the equation of the parabola that's going to do that? When I'm sliding it left to right, what happens to the equation? Anybody? Yes. Okay, I'm going to add and subtract, but basically I'm going to make this go to 0. Yes. So if this is going to be a 2 right here, then it's going to be a minus 2. Remember, when it's inside the function, we slide it the opposite way that we see it. We see it going plus 2. So it's basically going to be x minus 2. Remember in our circles it did the same thing. When we put them in vertex form, it was x minus h. And that was the center of the circle. Okay? So we have always done this with parabolas, with whatever we're doing. If we are moving inside the function, we make that center part 0. So if we're wanting to put in a 2, 0, this has to be 0. So we put in the 2. 2 minus 2 is 0. Now we're going to translate that over here to our sinusoids. Now to do this, let's refresh. What does my very most basic parent function sine look like? Okay, so a sine, remember, starts at 0, goes up, comes down, ends at what? Starts at 0, ends at 360, halfway between it's at 180. It's high at 90. It's low at 270. That is my very most basic parent. Y is sine of theta. Okay? Now, then remember we had a lesson that would change that baseline. Okay? If we needed to change that baseline because our function was going higher or lower. And we also had something that told us, well, we had an amplitude to these functions. They went up, they went down, okay. And we learned to add a few more things into our sine function. So now, this one is just a basic up 1, down 1, starting at 0. But now notice that if I'm looking at this as a sine function, remember sine functions and cosine functions are the same function translated 90 degrees left or right. They're the exact same function. They're just slid from one to the other. So now, if I'm comparing these two, my normal sine function starts at 0. The one I am observing starts at negative 45. So first of all, we'll check and say, is this a normal sine except just slid over? So a normal sine has a period of what? 360. Well, if I took 315 and I subtracted a minus 45, would that still be a 360-degree span cycle? Okay, so this is just a normal sine function slid back 45 degrees. Okay, so if I'm going to write its equation, it's going to be y is sine theta. Now, if I was going to slide this back 45 degrees, what would happen there? It'd be a plus. So now you're sliding this back 45 degrees. So what do you think this is going to look like? Sine theta plus 45. Okay, now let's go through the equation with a few points and see if that makes sense. If I plug this one in at 135, my function is 0. Well, plug in 135, and I get 135 plus 45 is what? 180. What is the sine of 180? Think about your trig circle. What's the sine of 180? 0. Okay, so the sine of 180 is 0, and that's what you get when you plug in the 135. So this looks like this is right? At 135, I get out a 0. Well, let's check 315. If I plug in 315, then my whole thing becomes a 360, and the sine of a 360 is a 0 again. So do you see how these points match the equation? Okay, now go over here to the next one. All right, over here. This one's got a little bit of a shift this way, and we've got an amplitude on this one. All right, and we're going to try to write this one in both sine and cosine. Okay, so now first of all, I'm going to kind of observe over here. I'm going up to 6, I'm going down to 2, and I know I've got to have a center line that's halfway in between. So 6 minus 2 is 4, so it's a 4-step span. So 2 steps up is going to be my center line. So what's 2 steps up from 2? 4, and then 2 more steps would get me to the 6, so that's got to be the right one. So it's going to be 4 plus, all right? And then I've got my amplitude. And my amplitude tells me I'm going to stretch up 2 instead of just up 1 from the center line. So I'm going to say that amplitude is 2, okay? And then I get into what we're teaching now. So the sine function, normal sine, starts at 0, goes to 180 to cross, finishes at 360. Okay, this one does look like it's a 360 period, so nothing else has changed, right? 300 minus a negative 60 is a 360 degree period. So it's a normal sine function shifted where? 60 degrees to the left. Therefore, this inside is going to be what? Plus 60 degrees. And then check a couple of points. If I plug in my 120, I should go to a 0, but not really a 0. I should go to a 4, okay, because I've shifted this thing up. So if I plug in a 120 here, what do I get? 120 plus 60 is 180. The sine of 180 is 0 again, so this whole part goes to 0. I get the 4. That's what my center line is, so that makes sense, okay? If I plug in my 300, I go to 360 in here, sine of 360 is 0, and it works. Now remember the cosine function is the same thing as the sine function, slid over 90 degrees. So our cosine function would start here. We're going to write the same thing as a cosine function. Now you'll notice in your book, it'll say, write it as a cosine function, write it as a sine function. If it doesn't tell you which sinusoidal function to use, they're all called sinusoids, right? If it doesn't tell you which one to use, you can use whichever one you want to. You don't have to put it in a sine or a cosine. You can use either one. All right, so on this one, the cosine starts high, and the cosine finishes high, wherever that is over here. But this tells me my starting point, and I know because it's just the same function that it's still going to be 4 plus 2 cosine. So now I'm going to look at where the cosine starts, which is high, and we say, okay, that's at 30. It's been slid to 30. So what would reflect here? If I'm sliding the same function to 30, it's going to be what? Minus 30. Okay, now, because I'm moving to the right, I'm going to move left a minus in my equation, right? So 30 minus 30 does give me a high point here. Now, I'm not looking for zeros now, because the cosine of 0, here's the cosine. Remember, the cosine of 0 is 1. My cosine is my left-right motion. So my cosine of 0 is 1, so I'm going to get a 1 there, which makes this a 2, and 2 plus 4 is 6. So it matches. If I go to 120, which is my 0 line, which is really 4, okay, I put in a 120 here for my theta, and I get 120 minus 30 is 90. The cosine of 90 is 0. So this whole part will go out, and I'll get just the 4, which matches the point. Okay, so after you have come up with your equation, it's always smart to throw in a couple of points. Say, does my equation match the graph? Any questions on that? Okay, so let's go ahead over here to one more. Can you hold that? Kind of put it on. All right, so let's do one more before we stop the thingy here. Okay, so this one right here is, let's analyze it. We have, it's going from negative 90, and it finishes one sweep of a sign at 270. So we say 270 minus a negative 90 is going to be a plus 90, right? Because it went minus 90 over there, and that is a 360. So we know we're dealing with a normal period length. All right, so if we're going to call it a sine function, we would start it here. If we're going to call it a cosine function, we would start it there. Right, so let's write it first as a sine function. So this sine function is going up to negative 5, down to negative 7. What kind of span is negative 5 to negative 7? 2. So we divide it in half. It's only 1 up and 1 down. So the amplitude of this one is still 1. But what is the center line? Negative 6, right? So I'm going to say y equals negative 6 plus, I'm going to call this one a sine. And it's only going up 1 and down 1, so I don't need a number in front of there. So now it's going to be a theta, and then we're sliding. The sine would normally start at 0. So this is a slide of what? 90 degrees to the left. So now over here I'm going to write this as what? Plus 90 degrees. And then I would be smart to check in a point, plug in a 90. Right? Plug in a 90 right there. It should go to 0. And if I do that, I get a 180. Sine of 180 is 0. So it checks. Okay, so check a couple points as you're doing that. Now let's do the same one as a cosine. Now, this is hitting the ground at negative 90. It's hitting the ground again at 90. Where is it high? Even if it's not labeled where it's high, you can tell where it's high.
0.
Halfway in between, right? It's going to be high at 0. It's a little bit off center there, but it's high at 0. So if we're going to do the cosine, we're going to start where it's high. Okay, so the cosine on this one, the cosine is the cosine displaced here. Or is this a regular cosine function? We know it's already got a 360. The cosine starts high. Halfway in between those is 0. So even though my graph is a little sorry here, this is already a cosine function graph, isn't it? Because it's high at 0, which is what cosine functions do. Therefore, it would just be cosine theta minus 6 cosine theta would be the equation. And you can see that the cosine theta and the sine are just the same thing, shifted 90 degrees, always. Okay, any questions on those? All right, go ahead and finish up your little quizzes while I get the board ready for the next thing.